Now, I'm James Montemagno. I'm a principal program manager on the mobile developer tools team here at Microsoft. That is a mouthful to just say, I just crush code all day on mobile applications. I love what I do, and I've been doing so for over 6 years. 6 years ago, I started my life as a mobile developer at a small startup in Kirkland, Washington. I used to write printer software at Canon. I thought printer software was a blast. Woo! After creating games for the Xbox, I was like, games on the Xbox, printer software, follow-up. That'd be great for 4 years as a resume builder. Slapped it on my LinkedIn page. Said, you know what, I'm moving to Seattle, coming to mobile developer, and I did it. And I used Xamarin. I found Xamarin like the very first day on the job because my boss walked into my office. He said, hey, we're going to CES in 2 months, the big consumer electronics show, and we need an iOS, Android, and Windows app. And he said, go. And I was like, you hired me. I don't know really much about Java. I guess I could lowercase things and pretend I know what I'm doing. You know, open up Eclipse. That'll be a blast again. And then Objective-C. I was like, I've never owned a Mac. I have no idea what I'm doing, but let's do it. And my coworker, Austin, he comes up to me and he goes, have you heard about this like mono Xamarin thing? He's like, just C# everywhere. I'm like, yes, let's do that. And that's what I've been doing for the last 6 years. I fell in love so much with Xamarin that I decided not to move to San Francisco, where they're headquartered, but I stayed in my bright, sunshiny city of Seattle, Washington. And I joined them as a developer advocate. So I've been working at Xamarin for 4 years and came along to Microsoft a year and a half ago during the acquisition because I love it so much. Everything that I do, I love. And I love giving it back to you. So all my demos, all my samples are all open source. I live here. I drink way too much of that. And I build tons of awesome things with this technology that I'm really excited to share with you. Now, you can find me anytime. This is my direct email, motts@microsoft.com. Montemagno.com is my email. Or you could just literally Google, Bing me, whatever, James Montemagno. There's one of me. You will find me on the internet. That's my Twitter and my GitHub. So all the samples, all my stuff is there. It's literally just my name. Now, if you want to hear more from me, because you're like, whoa, James, 3 sessions today. I was in all of them. That was awesome. Where can I just hear more of you? Well, you can, because I love it so much that I don't stop talking. I have a show on Channel 9, which is like our YouTube for developers here at Microsoft. It's called The Xamarin Show. It's a show about ASP.NET Core. No, I'm just kidding. It's about Xamarin. I bring awesome people from the community, awesome things that we're doing here at Xamarin and Microsoft every single week. And I also have a podcast that I do in off hours called Merge Conflict, which is an awesome name. It took us 2 years to come up with. So if you like anything, we talk about not only just mobile development, desktop development. Right now, we're really into machine learning and augmented reality. So if you like podcasts, check that out. Enough about me. Let's talk about native cross-platform development. And when I got started 6 years ago, I didn't really know what it meant to create a native application. You know, I was downloading all these cross-platform frameworks. Something was like websites and HTML, JavaScript. I don't know what all this is. And I started booting up some of these things, and I'm like, this doesn't look native. So what does it mean to create a native application? And what does it mean for our customers, whether they're on the App Store downloading it or internally and downloading it from Intune or something like that? Or just as a developer, what do I want to have access to? And first and foremost is we want really rich native user experiences. I think I said it earlier today, but I'll say it again, is there's a reason someone bought an iOS, Android, or Windows device, or a Mac or PC hardware. They like the hardware, but they love the software. So we should give them apps that look and feel native and actually be native on those platforms. There's nothing worse as an Android user myself of opening up an app and it looks like an iPhone app and I just get so mad and I uninstall it immediately. I do. That's what happens. I just get so frustrated because I was like, if I wanted iOS, I'd get it, but I don't understand that operating system. So then, as developer though, when I'm developing for every platform, they have a lot of similar features, but a lot of unique features too, whether it's something with Cortana or Siri or Google Now or something like that. We should be able to integrate every single API into our applications. So we should have access to everything. And of course, they have to be super performant, super native. So my users are delighted. Now, when we get into it, how do we build those applications? Many of you, or some of you, maybe have been doing some mobile development for a bit, live in the silo approach, which is essentially building the same application 3 times in 3 different programming languages in 3 different IDEs. In fact, you have 3 sets of unit tests, probably 3 sets of UI tests, 3 different DevOps pipelines that you're building it all in, and it gets really unruly really fast. This is what I thought I was going to have to do, right? You just go over here, and it's gotten a little bit better now. We have like Swift and Android Studio, but I'm still in 3 IDEs, so my team is really fragmented. So I can't really use the building blocks that I know and love to build native apps. And I'm not sharing any code, so it's hard to add new features to all the apps. So I'm like, I'm just going to shove all my code in a box and then boom, apps, right? That's what my parents think I do, just jam on a keyboard, apps. That's what they've thought for the last 10 years. They're like, you use a computer? Yes, that is what I do. I use the machines and the codes into apps. And this is what I thought of cross-platform development when I got started, which is like I just write some code and then plop, apps come out. And this write once, run anywhere, there's a whole bunch of different frameworks. There's a dime a dozen because a lot of them, if not all of them, are all web technologies. Every day there's something new. And often they're just running in a web browser, so you're not ever going to get that native user interface that your users want. And since they're in that browser, they're not getting that optimal performance. And if you want to go access an API, you have to go through their abstraction, not the API. Or if you want to, you got to go write the Objective-C, Java, or C# anyways. So you're not getting this great performance. Now, when Xamarin thought of cross-platform development, they wanted it to be native first. And that's really our promise, is delivering beautiful native apps across all platforms and sharing tons of code, writing everything in C#, the best programming language, and creating beautiful UIs for all of them, and accessing all those great features. So you build out a shared code base, all your business logic, models, view models, RESTful service calls, SQL databases, Azure integrations, things that the user interface and the operating system don't care about. And it's all in C# and .NET because we have a great .NET runtime that runs on every single platform. Then you have access to every single API inside of each platform. And that's how we deliver shared code, native UI and API access, and high performance. So how it works under the hood is I've been a long-time Windows developer. I wrote a lot of printer drivers, printer desktop software. That was a blasty blast. And then I wrote a lot of developer tools when I was at the game studios. And I was always a Microsoft Windows developer. I went through the WinForms, the WPF, the Silverlight. Microsoft told me to do something, and I did it. And I was pretty happy almost all the time because I had the best IDE, Visual Studio, and .NET. When I found C# and .NET, I was like, and I was like, look at all the stuff I can do. Yes. I was like, that's what I want. So I have Windows, right? Now we have a .NET runtime. Sometimes it's just on the server. Sometimes it's on a Windows machine. And I basically have .NET that's there for me. And when I want to go to a specific platform, maybe ASP.NET or WPF or HoloLens or some UWP hardware, well then I get an SDK that I simply integrate into my app. And you can actually share code between all your Windows apps. So it's pretty nice, right? You can think of it exactly the same now for every single platform that you want to target with Xamarin and Microsoft and Visual Studio. We just give you all that .NET goodness on the bottom. And then we create C# bindings around every single API in iOS, Android, Mac, and of course everything in Windows that you already have. And then we add C# features like async await, lambdas, events, delegates, things that we know and love. So even though I'm accessing a native feature, a native API, a UI kit, or a map kit API for iOS, it's all in C#. I never have to write Objective-C or Java or Swift. I do the same for Android. We not only offer up all the Android core APIs, but everything in Google Play services, Android support libraries, everything that a Java developer creating Android apps would have. So you can truly do anything. Now when it comes to the user interface, we have two approaches. And I'm going to start and mix around a little bit with our Xamarin Forms user interface. I'm going to demo it here and there, and I'm going to jump back and forth. And that's our shared user interface, which is usually where a lot of developers start. When they go into Visual Studio, they say File, New, they create a cross-platform app and a cross-platform UI. There's a session on Thursday with David Ortnow, the program manager for Xamarin Forms. He'll go really in depth in tons of Xamarin Forms. I'm going to do some demos here and there. But basically what we have is a shared C# business logic base. But we've abstracted all of the common user interface controls into a nifty library, an app infrastructure that you can take advantage of. But you still have access always to the native APIs of iOS, Android, and Windows. Now, to get started faster with development, we created the Xamarin Live Player. Xamarin Live Player is an application that works with Visual Studio and Visual Studio for Mac that you download from the App Store, you pair your device with Visual Studio, and you run your app on it with no compilation needed at all. It's super awesome and enables you to be super productive really fast. So you have some code, you scan a barcode, and boom, there's your app. It's essentially so you don't have to worry about emulators, simulators, Mac build agents, all that stuff. You just want to run your app. Because I just download tools. Let me get started. That's what I want to do. So here's a little demo of iOS here in Visual Studio 2017 that I actually showed this morning, of going in, dragging and dropping some XAML, and boom, it updates in real time. And I figure why not just show it a GIF. Let me just go ahead and show the code. Now what I'm going to do over here for the Xamarin Live Player is switch over to my PC. Here it is. And I have my Android device that's being screen mirrored. And it's my real device that I use for day to day. And that's a little scary, but it's the only one that I could get on the Wi-Fi. So here it is. It's on the Wi-Fi. Here, that's good. My little hotspot, little hotspot. I'm going to open up Visual Studio 2017. Now this is a preview feature, so it's in the preview. And I'm running both versions of Visual Studio side by side, which is awesome. And what I did is I said File, New Project. And normally I'd come in and just create an Android project or an iOS project here, or even an Apple TV application. But I created a new cross-platform Xamarin Forms app. And this is basically the source code that it gives me. It gives me some app structure and some resources that I could do, and I create a new page, and that page says, welcome to Xamarin Forms. So I could actually try to compile this application. I could do everything and deploy it, but I'm going to use the Xamarin Live Player to be super productive. So I'm going to go in, I'm going to actually pair. Let's actually do this. Let's take this, shove it over there, put that there, move this here, boom, and this, and this, and this. Cool. So let's do this. Tools, Xamarin Live Player, Manage. What I'm going to do is launch the Xamarin Live Player application. This is the application I downloaded from Google Play, just the App Store. And what it's going to do is just pair over my local Wi-Fi to Visual Studio. So there it is. Say, hi, everyone. Whoa, look at so many people. Cool. I'm going to probably upset the camera. There we go. Boom. It's connected and it shows up. And if you already scanned it, it's just the same one over and over again. So there we go. So there's my Motorola Nexus 6 player. Now this is plugged in because I'm screen mirroring, so you can see it here. But what I'm going to do is actually pick my player and then just hit debug. And what this will do is over the local Wi-Fi is actually send all of the files that I need to my device. So let's see what's happening here now that it's in this state. So it's synchronizing all the files. And then on the actual device, once the files are there, it's going to interpret the source code, or give me an error because I have some source code that doesn't work. So let's delete that. So that's actually cool. I didn't even try that. But did you see what happened is Visual Studio got the error from the app. So it's talking and saying, hey, I couldn't actually interpret your source code because you didn't do it right, James. So actually, let's ship the source code back over, and it'll do a diff. So it only has to send that one file back out, and now it should actually be able to reinterpret the application on the Android device. So we'll give it a second here while it's compiling up, and boom, there's a beautiful, lovely Xamarin Forms application. It's lovely. But what we can do is do a little bit better here. So what I'm going to say is debug, stop debugging, and we're going to come in and say Xamarin Live, run this view. Just run this current view, and there it is. So I should be able to say like light coral, for instance. And then this will take my changes that I have in the IDE, ideally, there we go. And it should send them over to the device. If I control, there we go, over to the device. That's a little bit hard to see. Let's go light gray. There we go. Oop. Gray. There we go. Now, as I'm kind of writing the code, it's essentially sending the diff over, and then it should update on the device. There we go. And now I can just kind of come in and add a bunch of stuff here, and that's looking pretty good. It's giving me a little error. Oh, let's not copy the stack layout. Let's go ahead and do this here. Boop. There we go. All right. Let's give it a, there we go. Cool. Internet. There we go. So now all my things are there, but I can come in and let's add a button. I'll say button, and I'll say text equals click me, and I'll say x colon name, and I'll say button click, close it out. There we go. We're going to save it so we actually generate some code behind there and it updates, right? That's cool. Now I could actually access that from the code behind. So I'll say button click dot clicked plus equals, enter in there, right, using Visual Studio. And when I want to click it, let's just say display alert. I'll say hello, and I'll say ignite, and I'll say OK. Right, I'm going to display a little pop-up because I'm in Xamarin Forms here. Now I'm just going to make sure that this refreshes on my device. So I'll say light pink. I know, there's so many colors. Now this will take all of the code changes from the UI and the actual code behind here and then deploy it onto the device. Make sure it gets over there. Cool. And I can hit click. Boom. And I've essentially just started to build out my user interface, access the code behind, because even though it's live running the user interface, it can still access all of the APIs in any of the operating systems, including Xamarin Forms API to do this. So I can start iterating on my UI. So if you're like, hey, I want to get started with Xamarin development, you can literally download everything. You don't even need like Java or Android SDKs or anything. And boom, you just download an app from the App Store, you're good to go. If I want to take my iOS device now, over local Wi-Fi, pair it, boom, same exact experience. I wanted to make it really easy to iterate on your application right from Visual Studio with just a device. And a lot of these devices that I actually use are little like $30, $40 devices on Amazon, so it's not a big commitment. So this way you don't have to worry about Hyper-V and Intel Haxum, all this craziness that you may need just for an Android emulator. So let me hop back over to the Surface. So that's how we're going to enable all developers to get started faster. And you're going to see Xamarin Live be even deeply integrated into Visual Studio. And as you progress and start building your application, take it even further. So we're really excited about the Xamarin Live Player capabilities. Now, the other part that I want to focus on is where a lot of developers go when they need really rich user interfaces. This is what I started development with 6 years ago, which is our Xamarin native traditional UI approach. And unlike Xamarin Forms, which was a shared user interface, this type of application development is where I'm going to build 3 different user interfaces all inside of Visual Studio. So for iOS, I'm going to build a storyboard. For Android, Android XML. And for Windows, XAML. This is going to give me access to 100% of the APIs because there's no abstraction. It's the same user interface designers that I would expect from Android Studio or Xcode. But it still allows me to share a bulk of my business logic in shared C#. Now, what's nice as we expand out, you'll see that these two worlds of Xamarin Forms and native development blend really well together as we progress on through this session. Now, that's the UI. That's a little demo to get started. But native performance is really important. And for me, I love how we optimize performance per platform. So each platform, iOS, Android, Mac has its own compiler, linker, and optimizer that essentially gives you a native binary for each application type. So iOS, we do a full ahead-of-time compilation. Take your C#, compile it down into IL, an intermediate language, and one more time down into LLVM bytecode, giving you a native ARM binary for iOS. And you just upload it right to Apple. And on Android, we can actually run our .NET runtime side by side Android's Dalvik or ART runtime, and JNI and Cross essentially to make those calls. So we use just-in-time compilation. Now to your users, there's no difference. You just download an app from the App Store, and it works awesome. In fact, you probably have Xamarin apps on your actual phone, and you probably don't even know. Or maybe other devices like Apple Watch or other tablets that you may have. And we support everything that we possibly can. We've had same-day support for iOS since iOS 5, including iOS 11, which just shipped last week, to enable developers to have a build ready to go after the long developer preview that they'd have had access to, so they can ship app updates but integrate new iOS and Android features into their applications. iOS is really important because 50, 60, 70% of all users upgrade to the new version of iOS within the first few weeks. Android takes some time. As an Android user, it makes me sad, but I think the last time I checked the dashboard, about 20% were on a year-and-a-half-old operating system. So it takes some time, but we do have great support, and we already shipped Android O support. But it's more than phones and tablets, even though it's what I demo heavily. We support anywhere that you want to go, whether it's Apple Watch, Android Wear, any of the Amazon Fire devices, Apple TV, or even Google Glass, as that I think is making a comeback. And this is in addition to all of the Windows and .NET applications. So you can share code, of course, with all of your UWP apps, HoloLens applications, and anything like that. Now, the code sharing that I talk about on average is with the Xamarin native approach to development, so building that native UI 3 different times. So it's really rich user interfaces with graphics and videos and photos. And on average, we share about 70% of code across all platforms. And iCircuit is actually by my good friend Frank, who I do the podcast with. It's a circuit simulator. He's an electrical engineer by trade. And he's sharing anywhere between, in blue there, 70% on iOS, all the way up to 90% on Windows. And that's because Frank is an iOS guy, so he really loves integrating the new crazy iOS APIs into his iOS version of it. Where the other ones, they get all the core features, and he spices it up here and there for the different platforms. Now, the cross-platform UI, when you come in with Xamarin Forms, takes it to another level because you're sharing your UI where you need to, or blending in some. So I built our Xamarin Evolve conference application last year, and I was sharing anywhere between 91% on Android all the way up to 98% on Windows. And you're saying, well, James, why isn't it 100%? Everything's shared, right? So you're like, sure. Well, it's because I'm an Android guy, and I was like, I'm going to add a bunch of crazy, awesome Android features. So on Android, when you walked into the conference, it automatically configured your Wi-Fi for the conference Wi-Fi. So I was able to access those native Android APIs to really delight my users on Android, where on Windows and iOS, those APIs aren't available. What's cool is that Xamarin is included with every version of Visual Studio, including Community Edition, so you don't have to pay us a dime for anything. For Community Edition, if you have Enterprise or Pro, of course, you're already paying, so you have Xamarin, you're good to go. What's awesome is it works in multiple IDEs. I'm going to demo Visual Studio 2017 quite a bit, but it works in 2015 as well. And of course, Visual Studio for Mac, giving you one place, well, two places to do all of your development on Mac or PC. In addition to that, everything's open source. So everything I'm going to show you from the SDKs, the APIs, a lot of the tooling are all open source under MIT, which have been including our .NET runtime. So with that, before I get into even more code demos, if you take one thing away, it's anything that you can do in Objective-C, Swift, or Java, you can do it in C# with Xamarin. So let's actually do an end-to-end app and integrate a bunch of cool stuff. So what I'm going to do over here is come into Visual Studio, just the normal edition, nothing crazy here. And what I've built out is an application that will go out and use our cognitive services and the Bing search APIs to search the internet for anything that I want, and then also do some facial recognition on any of those images, but also if I take any photos of faces or anything like that. So it's kind of like an image analyzer in a way for emotions. So inside of this project, I've gone and I only have Android and iOS, but I could also add UWP or other types of applications here, but I'm going to focus on Android and iOS. Now here I have a shared project, and we share code in a lot of different ways, whether it be shared projects, .NET Standard libraries, or portable class libraries. There's several code sharing strategies. And this application is relatively simplistic. It has a data model here, so what an image will look like in the results, so a thumbnail link, image link, file format, title. And then I have some Bing results that are coming back. So here I have a search result. So it's a bunch of JSON that's coming in. So there's like read link, web search, all this stuff that's coming in. I've added JSON properties to clean it up. And then I have an emotion service, and I'm using cognitive services to use our Project Oxford emotion service. So any of the images I could tap on and say recognize based on the stream, any of the faces, and I can calculate how happy any of those faces are with a few lines of code, all using async await programming here. Now the bulk of my logic is here in my view model, which is what I want to expose to my application. So here's what I'm going to do is I'm going to come over here, and my view model has a few things, such as an observable collection of images. It has a selected image, and it has a method called search for images async that takes in a query. Here's that Bing API that I'm going to hit, and I also have a Bing key that I'm going to pass in. So I'm just in my shared code. I'm not talking about iOS or Android yet. I'm going to write some code that's just going to be executed natively on each platform. So I'm going to come in, and I'm going to say var client equals new HTTP client. I have all the systemnet HTTP stuff there. I'm going to say client dot header requests dot add, and we'll add in the header key and header value. So some authentication there. And then I need to get some JSON from the actual web API call. So I'm going to pull that down. I'll say var JSON equals await client dot get string async and pass it the URL that I specified up top. But you can see I'm using modern C# features like string interpolation and async await here. And then what I can do is, like I say, I have that JSON. Let's go ahead and convert it to a result. And that'll be a JSON convert .deserialize object. That'll be a search result. I'm going to pass it some JSON. So I've brought in a few APIs here, some NuGet packages, so json.net, to deserialize the JSON. And now these are actually going to be search results. So these search results need to be converted into my image result. So it's a nice simple thing. So I'll say var images, and I'll say result dot. And I have all that stuff that's in there. It's very complex, but I don't want all that complexity. I just want to go ahead and use my favorite feature, one of my favorite features of C#, which is link, to just say, hey, let's convert those in real time to a new image result. There we go. Cool. So now up here what I can do is I can start filling in some information. So I'll say context link is the content URL. The file format is the format, encoding format. Image link is the, I think that is the content URL. I think this is the host page URL. There we go. The thumbnail link will be i.thumbnail URL, which is sometimes null, so just say content URL. And then the title, and I'll say name, i.name. Perfect. Convert those all in C#, and then I can just say images dot replace range, pass it the images. Boom. I'm essentially good to go with my shared code. And if anything goes wrong, I'll just return false and do nothing. That's pretty good practice, I think. Works when the internet's working, so that's good. So this is pretty simple, just some .NET code. And now we want to integrate it into Android and iOS. So I'm going to first come up into my Android project, and I'm going to say Start Project over here. And my Android project has, if I right-click and go into the NuGet packages, I have tons of awesome NuGet packages inside of here that I can use to pull down images and .NET libraries. Basically anything on NuGet, if it's compatible, you can just bring in. So when I go into my resources, I'm seeing first my shared code, because I'm going to add all my shared code for this application. And then I have some other things such as systemnet HTTP, extensions, and all the Android support libraries right here. So I can actually add a lot of nice logic. And under resources, let me zoom back in, we have all of the Android native user interface that I'm going to put inside of here. So I have drawables for like icons and images that are inside of here based on the different screen density. I have some layouts and values for styles and different translations. I'm going to open up this layout folder where my main user interface is going to live. And when I tap on that Android XML, it's going to launch our Android designer inside of Visual Studio. So I'm going to pull out my toolbox and click over here. Well, this spins up. And this is going to give me a native Android design surface. And I have all of the Android widgets right here. So if I want text or a switch or a pointer or text fields, it's all here. In addition to that, we pull in any custom controls you have and anything from the support libraries like card views and floating action buttons and all that jazz inside of there. So we'll give it a few seconds. This is literally the first time that I'm spinning up the environment here. And I have my Android user interface inside of here with my own theme that I brought in. I have an edit text here, I have a button, and I have a recycler view, which is a super highly optimized, crazy list view in Android. And I have this UI already defined, so if I tap over on the source code, we can actually see all of the Android user interface that's here. So I have a linear layout, a relative layout, and it's all Android because it says Android, 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 Android everywhere. And it's the same exact Android XML that a Java or Kotlin developer would use. So I can see I have an edit text where I'm going to edit something, and I'll put cute monkey because that's always what I always like to search for on a daily basis. And I have some progress bars and buttons and this recycler view here. So what I can do is essentially access all these API or these UI elements from the code behind. So the code behind is a main app activity which defines all the life cycle events for that page. So inside here I'm going to do a few things. I grab the toolbar up top and I start to first pull in my shared code, so image search view model. And I knew that up because my goal here is to create the UI, access to the UI, but get right into my shared code as fast as humanly possible. So what I do down here is I say, let me grab the progress button or the progress spinner, the edit text that's coming back, and then that button that's coming in. So now that I have that button, I'll just say button.click plus equals, and I'll just do a little click handler inline and add my little lambda. There we go. Now I can just start accessing all of the actual APIs here. So notice that I didn't have to override anything. There's no crazy Java stuff. We've converted and improved the Android APIs. So there's no get compound top padding. There's just compound top padding, which is a getter and setter that you would expect. So we've improved these APIs. So if I want to enable it, I just go to enabled. It's a get and set. And I'll just say false. And I'll say button enabled equals true. And I can take that progress spinner and say visibility. And we take any enums that were maybe integers and we turn them into .NET enums. So let's make that gone. And when we're all done, we'll say progress.visibility equals visible. There we go. Now I want to call my shared code. So what I'm going to do here is simply say await viewModel.get, search for images async, and then access whatever query I passed in. Boom. Just written a few lines of code here to enable me to access that native UI element. I have a few more things out here to actually put these images into a very nice collection view, if you will, of grids and rows. So I'm going to specify an image adapter and a grid layout, which is a recycler view grid layout, and say, give me two images or two columns in this grid layout. If I go into this image adapter, it looks kind of similar to what I just did in my main activity. I have some click events whenever I click on something. Whenever the collection changes, I update the actual recycler view. And then down here, I just say, hey, inflate an item element, which is a nice little card view. And then down here, I assign what's going to be displayed on each cell. So I update the text of the caption, and I use Picasso, which is a library from Square, to download all asynchronously all my images. So now at this point, I can come in to my view model, and I can start adding some breakpoints here. So we can just do this here. And what I'm going to do is just actually run it on my actual device. So I'm going to hit debug. This is going to now actually compile. I'm not using the live player. I'm going into a full debug. I'm using all sorts of crazy libraries. I want to access some native features like camera and things like that. And what I'm going to do is do a full compilation. What this will do is compile everything and then launch it into a debug session on my actual Android device, which is pretty nifty. So it's going to take a few seconds because the first time you compile it, it'll compile up all the assemblies and everything we need, and then it'll do diffing based on that to actually do additional faster compilations. So give it a few seconds. It's going to now finish up the packaging and signing of this application that will enable it to go on the actual device. So we can see some of the Java things are leaping into action here, and I'm deploying to my Motorola Nexus 6 physical device. We'll give it a second. Things are happening. I trust it. You can look at what I look at every day. Use like the Nintendo Switch app, which was built with Xamarin, so that's cool. Using the new Dev Center app, that's cool too, built with Xamarin. Go geocaching all the time. What else we got? There we go. Whew. Like when it works. There we go. So now it's actually going to deploy, and boom, now I'm in a debug session. All right, cool. And we got that beautiful UI that I have here, and it says search for cute things. I'm going to search for a cute monkey. I'm going to hit go, and what we're going to see is that it goes off, makes a network request, and actually pulls down some JSON. So here's this huge bulk of JSON. It's all gross. Look at how gross that looks. We don't want that JSON. We want that C#. So remember here, I'm using JSON to C# to deserialize it. They're saying, James, how did you figure all that stuff out? You went line by line and like pulled it in there? No. I went to this awesome website called quicktype.io, which is by some developers here at Microsoft. And what this gives you is a side-by-side to actually convert JSON to almost anything. So C# here. Here's a bunch of Pokédex information. I'm just going to paste the actual JSON in there. And now I could say like image result. This is awesome website. I can then copy all of the C# with all the JSON properties, all the serializers, anything, and all the converters back and over there. It's bananas. It's super cool and open source. QuickType.io. So that's how I got it there. And people are like, whoa, that's cool. I didn't even have anything to do with that. But it's great. So now I come back over here. Boom, I've deserialized those results. I have all those 20 images coming in right into the user interface. I could look at all of them, and then I'm going to convert them and display them into the user interface. And boom, adorable images of monkeys. And apparently I still have the spinner going, and we can fix some code now. So that's cool. And I can scroll through, and I see cute, cute. You guys are just going to look at like, dashboards all day and Power BI stuff. And I was like, you got to get some monkeys in there. Look, cute. That's a tiny monkey. That one's eating a banana. Cute. Awesome. So now, this is basically my job, and I love it. So I just look at cute monkey photos all day. Now we can take this exact same application and do it over on iOS, right? So we could then create a little bit of user interface on iOS and get the same type of app. So I'm going to go over to iOS, open it up here, and I have all my references. So all my shared code, everything that was coming in, and some bunch of NuGet packages that I pulled in as well. When I tap on this main storyboard, this is going to bring up our iOS storyboard designer for Visual Studio. It's also going to pull in our toolbox. There we go. At this point, what it's doing is I'm actually connected to my Mac. It's my rose gold MacBook, adorable. It's right there. And it's connected over local Wi-Fi. So once I've outgrown some of what Live Player can do, and I want to use the designer, I want to do a full compilation and packaging, I essentially pair Visual Studio with a build host that's running on my Mac. And this will enable me to do full compilations, use the designer, and then also package it and ship it up to Apple. So this brings in all of the actual user interface controls over here. So everything that's here. So everything that's available in iOS I can add in. And then we'll get our design surface over here. So we'll give it a second as it spins up on my AT&T hotspot. Got this. Oh, there it is. Oh, almost. Uh-oh. There were problems. Try again. Well, make sure I'm connected. Connected. Try one more time here. Set that as the startup. Bup, 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 bup. Give it a go. And what this is doing, like I said, it's connecting to the Mac over a secure SSH connection. And then ideally, if everything is going correct, should bring in our designer. So it's actually a remote designer view. Come on. It's got the controls. That's good. I feel like it wants to really bad. It's like, I got this. And then it's like, no. And you're like, all right, James, whatever. The cool thing is I already built the user interface, so we can just access that user interface from the code behind. Skip over that. So inside of this project, I created like a collection view of images. So what you would have saw, there was a very similar user interface to Android in the designer. What's happening with the Wi-Fi, but that's OK. And what I'm going to do here is I have a collection view, a button that I can tap on. I'm going to come into this view controller. So it's a UI view controller, which is the code behind for a screen. So I start bringing in my shared code. I have a collection view, some text fields, and a button. So I'm going to access the button, which is button search. And I'm going to say, instead of not click, I'm going to use touch up inside, which is the iOS event for a click, because I've touched down and up inside of the button still. But even though the name's a little bit funny, I can still use all of my C# features. So async sender args, add that little lambda. There we go. And then I can just start accessing the user interface. So I'll say button search dot enabled equals false, but this time I'm actually accessing the native iOS type of stuff. Button search dot enabled equals true. We have a little activity indicator that's a little spinner. I'll say start animating. And I'll say activity is loading, stop animating. Now all I need to do is go out and say await view model, reach into my shared code, search for images async, pass it a query, so text field query.text. There we go. And now what I'm going to do is make sure that after I'm done, I'll say collection view images dot reload data. And that's it. It'll then know to say, hey, I need to refresh the user interface based on this. And what I said down here is like, hey, for every cell, this is what it's going to look like. I have a cell. It's called an image cell. Grab the current image for the row and update the title and set the image for me right there. And now what I can do is come in and make sure I can compile this up. It's going to compile all of my C# code locally inside of Visual Studio. And then when I actually want to deploy it onto an actual simulator with a full compilation, it will then do a, oh, I typed something wrong. Perfect. Perfect. I'll just hit debug. So now after it compiles the C# code locally, it's going to then send it over to my Mac to start a remote debug session inside of a simulator. So give it a second to finish up the build. There we go. Bup, 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 bup. And what we're going to see is that our remote iOS simulator for Windows will pop up. Boom. And what we've done so developers have a great experience, since Apple doesn't ship their SDK or simulators on Windows, we actually remote the actual simulator over to the PC, including touch events and everything like that. So we'll see as it launches. I have faith in this emulator. Oh, I did have faith in this emulator. My iOS is just having such a hard time today. Let's do a clean and rebuild for fun. Bup, 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 bup. Rebuilding, rebuilding, rebuilding. There we go. Now what we'll see here is that there's all these different simulators in here. So this is my favorite, the 5S 9.3 simulator. So I'm going to try it one more time. Should communicate off to the Mac and make sure things are happening, unless I've run out of data, and that could be some sort of issue. Let's log into my AT&T account. Nope, still good. Boom. Apple, good. Launch. Or we can try another. Oh goodness, there we go. Cool. It's always great when everything works perfect at home or in your office and then conference. So here we go. Here's the user interface I was showing a little bit before. I have cute monkey. That's what you would have saw. I'm going to hit search here. It goes off, have a little spinner. I'm going to hit those same breakpoints that I had for Android. So I'm kind of productive because I'm just debugging both my applications, and boom, a bunch of monkeys that we saw. And now notice that I'm using my finger. You're noticing I'm just using my finger here to scroll up and down because we forward the touch events over to the Mac, which is bananas. And what's cool is I can, of course, use my keyboard. So I can come in and say, give me a cute panda, because monkeys are cute. Pandas are also cute. And there they are. That one, oh, did you see that? Oh, my God. That's cute. Again, they literally pay me to do this, and I love it. So there's a cute pandas, cute monkeys. Now we're good. Now, I said I wanted to do some facial recognition, though. So what I could do is I could come in, let's say, into my shared code again here. And I wrote a little method that's called analyze image. So what I could do is I could maybe tap on any of those elements in there, and I could analyze the stream to my emotion service, and then pop up a dialog box. You're like saying, well, how do I access dialogues, and how do I access a bunch of stuff right here if I'm in the shared code? Well, that's because what we devised is a way for developers to access native APIs from shared code. What I'm going to do is take you over to xamarin.com/plugins. And what plugins for Xamarin and Windows are a way that we've abstracted common platform APIs like geolocation, media, contacts, push notifications, pop-up dialog boxes, connectivity, the file system into a single API. So what we can do here is we can actually browse plugins. And plugins for Xamarin take you to our open source page where we have all of our open source data bindings for libraries like Google Play and Facebook. And then down here are community-driven plugins. So like, oh, James, I want to do this thing. Like, oh, I got to go learn iOS, Android, Windows, so I don't know, access Bluetooth. Nope, we have it all abstracted, all driven by the community under MIT. So we have things like audio recorder, connectivity, device motion, file system, fingerprint, geolocator, in-app billing. That's a cool, all this great stuff that you have access to. So let's say I want to not only just do facial recognition on those images, but I want to make sure I'm online on the interwebs. I might be on airplane mode or something. So I'll go ahead and look at this connectivity plugin that's built by someone that has a cool name. We'll go over to the GitHub page. Like, whoa, this looks like everything I wanted and needed in life. A connectivity plugin. Man, like, look at all this. Like, who's this developer? Like, whoa, cute. Like, that's good. I don't know. Like, maybe works at least on the ASP.NET team. That's cool. Like, pushes code a lot. Let's use this library. So what's cool about these plugins is that they work almost everywhere. So this one works on iOS, tvOS, Android, UWP, Mac, and WPF applications, which is really cool. And since they're all open source, you can just take a look at the source code. So inside of here, I'll look at the source. I can look at the abstraction here. So I'll look at iConnectivity. This has things like is connected, is reachable if I want to ping a server, get connection types, bandwidths, and even see when the network changes. And what's nice here is that those are Android and iOS specific calls. And this is why Xamarin makes it so powerful to access those. So inside of here, I'm going to access all of the Android Wi-Fi and networking APIs because it's an Android API. So in here, you can see all of the Android code that you don't have to write because I already wrote it for you. Because who doesn't want to check connectivity or in-app billing or do all that stuff? Like, look, all that code. I did it because I love it and because I wrote this code once and then I never wanted to write it again. So I put it in a nugget and shipped it up there. So I've installed this NuGet, and let's do 3 things. Let's first check the internet. If something goes wrong, pop up a dialog box, and then tap on a photo and do that facial recognition. So I'm going to come up top, and we have to search for something. So I've brought in, if I go into all of my NuGet packages, boom, I have some dialog boxes, user dialogues. And then down here, I have some permission requests. So if I want to bring up the camera, that needs to be in there. I also have, somewhere down here, connectivity, geolocation, and a cross-platform media plugin to take photos. We'll come back to that in a bit. So let's come up here and we'll just say, hey, if not cross-connectivity, which is the API, .current, .is connected, I'm not connected, well, guess what? Return false, because you don't have internet. And let's go ahead and say, await user dialogs, .instance, .alert async. So it's a cross-platform API. So I can now come in here and say, message, you need the internet. We all do. And return false. So there we go. I can add a breakpoint here. And now what I can do is simply set the Android as the project. And we can then come into the source code to actually tap on one of those images that are coming up. So I'm going to say adapter.item click plus equals async sender args again. There we go. And what I'll do is just say var image equals args, or sorry, view model dot images args dot position. So I'm just going to grab the current image out of it. And then what I could do is call that API. So I'll say await view model dot analyze image async and pass it the URL. So I'll say image dot thumbnail link. Boom. So now I'll just compile this up. I've just added 3 or 4 lines of code to tap on an image, but all the bulk of it is going to be handled over in my view model. And this code works on both iOS and Android. All I'd have to do is add a little click handler over on iOS to get that capabilities. So there we go. See how fast it is after you've done it, a little compilation once. So now what I can do is I can come in and let's put this into airplane mode. There we go. So I'm going to say search, and boom, I'm no longer connected to the internet. It reached into the Android APIs from my shared code with a single line to actually tell me if I'm connected to the internet or not. I can go ahead and continue on, and boom, I pop up a dialog box that I need the internet. Now the moment here that I take off airplane mode and hop back onto the internet, there we go, and now I hit search again, it's going to go off, query everything, and pull back all my monkeys. Now if I tap on one of these monkeys, it's then going to go off and attempt. It actually found a little monkey face in there. That's pretty good. A lot of the monkeys it doesn't work on because they're monkeys, and it's hard to analyze because they're monkeys. So let's add a different type of monkey. And see if we can. Some monos be running all over the place. And there's me. Cute. So cute. My mom just keeps telling me that, so I believe eventually that I am cute. So, but I have all these images, and look how happy I am literally all the time. Look, what's that? Well, we can do kittens. I don't know if they can detect the cute kittens. Maybe a kitten. Oh my, yeah, also adorable. See how this works? It's just adorableness all the time. All right, let's take it to the next level, right? So what I'm doing is I'm now accessing some native capabilities, accessing that stuff, but I also brought in that media plugin. So why don't we try to take a photo of my face here too, or pick some photos and analyze those from a gallery. So in my shared code, I brought in the media plugin. And a little bit as I scroll down, I have analyze, but also take photo and analyze async. With just a few lines of code, I'm going to initialize the camera and say if I want to use the camera, take a photo asynchronously or pick it, and then I'll take that actual photo stream and pass it into my emotion service. Cool. So now what I'm going to do is go back over to Android, come here, get rid of this click handler. I'm going to say set up camera. What that'll do is down here, we'll add a different click event, and we'll add a little floating action button that I can pick. Oh, we don't need this one yet. There we go. Let's get rid of that one. So just a few lines of code there. So we can go ahead and pick this here, recompile up those changes with all this shared code that's coming in right here to take the photo and analyze the actual image. There we go. All right, cool. So now we have that little floating action button on the bottom right, so we'll tap on that. There's the camera, there's everybody. Let's flip it around. So this is like pre-keynote. I was like, I'm so scared. That's accurate. It's going to go off, talk to cognitive services in Azure, return a result to me. Boom, 0%. Whoa. It's not good. Let's see if we can change it around. This is like after Scott was like, high five, crushed it. And I was like, it'll be like not as happy. Let's see. So now it's going off. 99.9% happy. It's pretty cool. And I'm using all the power of Microsoft Services, Visual Studio, and all this here. And of course, I can now come over to iOS, just like I thought before, right? And I can come in. And what I'm going to do is do a setup camera. And this is one little method that comes in, and since I'm in the simulator, we'll essentially add a button in the top right, and it'll just say, let me just pick a photo asynchronously. So I'm going to tap on that, set the iPhone simulator, and debug it again. And ideally, everything is still here. Perfect. So now I'll just take my changes, the changes that I was working on them for Android, and then a little bit of UI change to just add a little item in the top right, and then deploy it again over onto my remote iOS simulator. So give it a second here. It pops it up, launching, 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 boom. And that's just a gorgeous splash screen that I created myself. So real good design. And now we can come in here and we can pick a photo. There we go. And we have some pictures of Miguel, who was our CTO and distinguished engineer. And I always like to see how happy he is because he looks so like unsure. And then 51, right? And now I can come in and say, Miguel, guess what? I'm always happy because I work for you and it's rad. So it makes them real happy. So I'm using these same services, sharing code across all of them in Visual Studio. Cool. That's really end-to-end. Plugins, you just saw plugins abstracting all these APIs so you don't have to go learn them. You have all the source code so you could learn them, but all access them from shared code. Now, I talked a little bit about Xamarin Forms early on, if you remember that with the live player, and that's what the Xamarin live player is for, to get started with Xamarin Forms development. And then I moved over to the Xamarin native approach, which is that shared UI, two or three separate UIs, crafting those out. Now, the nice thing is with Xamarin Forms, you just share more code on top of it. So all those models, view models, I share all that. But I add in that Xamarin Forms shared code layer logic. Now, what we did is we abstracted as many different layouts and pages and controls that we did, because as you want to do rapid application development, You also want to scaffold out really, a lot of apps really fast. So if you're doing a lot of data entry applications or things like that, this is going to be perfect. But also, if you're adding some screens to your existing app, this is going to be great too. Because I have a full two-way data binding system, an animation system, dependency service, and messaging center. We actually have a full MVVM framework built into Xamarin Forms. So what's cool here is if you looked at Xamarin Forms, like I said, I'm not going to go too in-depth because there's David's doing a session. If I was creating a login page, I'd create it in tabs maybe or something like that. And I have tabs here, and I'm inside of a tabbed page. And I have two pages, a login page with username and password and a button. And then I have tabs on the bottom. So down over here, we can clearly see, as I walk off stage, is that we have UI tab controller doing tabs on the bottom with icons, material tabs on top for Android, and on UWP, whether you're on desktop or on mobile, it shows the correct tabs. And then all the data entry fields are native because everything with Xamarin Forms, even though it's all a shared XAML, lays down native controls. So that UI, or that data entry field is a UI text field, an edit text on Android, and a text box on UWP. Now what's cool here is we're transforming this. You can build your entire application in Xamarin Native, or you can build your entire application in Xamarin Forms, or you can blend them together, giving you the best of all worlds when you need some pages to be super highly optimized with lots of rich media and content, but also want the ability to scaffold out pages really fast. And we call it Xamarin Forms embedding. So we take the monkey application, the image search application that we have here, which is this, iOS, Android, and Windows, and that shared logic there. And what we do, watch this, whoa, animations. You add in some Xamarin Forms goodness, and you can blend these worlds together and still access 100% of the APIs. This works with straight content pages, but it works with all the great features of Xamarin Forms, such as dependency service, messaging center, and a whole bunch of other awesome stuff in Xamarin Forms. So let's go over to Xamarin Forms really quick in this application and add in maybe a detail page. Whoops, wrong one. So I'm back over in the same exact solution. The only thing that I've done is when I go into my NuGet packages, I've installed on the way bottom, because it starts with the Xamarin. There it is, Xamarin Forms. So there it is. This is the 3.0 version. This is a preview feature of it. Installed that. Now what I can do is I can come into my shared project. So if I want to add a details page, a settings page, an about page, I don't really need them to be all crazy fancy animations, all that stuff. I just want to lay down some controls. So I have a view, and I'm going to say new item. And what I can do is go into Xamarin Forms. And we have a bunch of templates to lay down content pages, list view, master detail, tabs, right from Visual Studio. So I've added a little details page here. Right? So just some XAML. So when I tap on an image, instead of doing the facial recognition, it will push this page across. So I have a scroll view here. I have a stack layout with an image. And I'm doing a data binding to the selected image, .image link. It will automatically download and cache the image for me. I don't even have to handle that. And then I have some labels to output the title, file format, context link, and even a button here that I can click to do the facial analyzation of it. If I go to the code behind, it's a Xamarin Forms XAML content page. So here I actually have a constructor that takes in the current view model and whatever image result I want to pop up and use. And I'm using compiled XAML, so all the XAML will be compiled into the application. And then I just set the binding context, and that's it. What's cool here is that I have a little button click, which also could have been an iCommand and all that data binding. But I can just access that UI, and this is the native UI that will be displayed on each platform to analyze that image. So to get it into the applications, it's actually really drop dead simple. You think it'd be all complicated? No, I just have this XAML page. How do I get it in there? Well, I head over to my iOS application, and when I tap on an item, it's literally 3 or 4 lines of code. I say, whenever I tap on that item, grab the image, create a shared details page, and then convert it into the native UI view controller. And using my navigation stack, I push it onto the stack. So now, when I come into this iOS application, I look at image search and launch it here. Since I've already deployed this code, I can tap on a monkey, boom, It pushes it across, downloaded the images, gives me the native stack and the native UI elements, and I can say Analyze Image. When I tap on that, I get the same results. I'm sharing all of that code. What's great here is that if I come over into Android, here we go, and I can enable this code here. I'm going to say, hey, whenever I tap on one, go ahead and start a new activity called the Details activity. If we go and look at that, over here, just a few lines of code. I come in, I have my normal scaffolding, I initialize Xamarin Forms, and I convert that details page to a native Android fragment, because that is what's actually being displayed if you did everything inside of a Xamarin Forms application. So I can now blend these worlds together, and if I tap on Android, set that as my startup project, and redeploy it again over to my device, it'll now blend together the worlds of those native APIs with those rich recycler views with Xamarin Forms. So here we'll go over here, tap on my cute monkey to search for it. Boom. Tap on that monkey again. And when I tap on it, it's going to initialize Xamarin Forms, pull down the image. I still get the native stack, everything. Of course, I can analyze that image and bring it in with the same exact usage. Now I'm sharing a bulk of now my user interface and my shared code across iOS and Android. And I can bring that same details page into a UWP application because it works there as well. Lovely. Boop, boop, and boop. Cool. The future. Now that's like that could be tomorrow or after the session, but things that just happened or happening in the world of Xamarin. Now that we've seen about building an application, a little bit about Xamarin Forms and where Xamarin Forms is heading with the embedding. There's tons of Xamarin Forms awesome stuff. We're standardizing XAML across all platforms here at Microsoft. These are things that David will be talking about. New things like memory reduction, fast rendering, XAML improvements, .NET standard support, a whole bunch of awesome stuff that I don't have time to get into. He's going to cover all of it. And at the same time, talk about how we're bringing Xamarin Forms to new platforms, including Tizen, macOS, Linux, and WPF. So you can actually target every single platform out there and embed Xamarin Forms page or do an entire application there. Now, beyond that, we have a great ecosystem of control vendors. Some of them are here, such as Syncfusion, Telerik, and DevExpress, that are making all those fancy charts and graphs and widgets. Those all integrate today into Xamarin and Xamarin Forms. So if you don't see a control that I was showing you, or maybe it doesn't even exist in iOS and Android, they have you covered. And we work with them to really optimize high-performant controls and charts across all platforms. Now, at the same time, we've worked on a lot of fundamental improvements, not only in Xamarin Forms, but in the core of Xamarin. And the first thing that I want to mention is that we're always all about native. Native first, whether it's the native APIs, native user interface, native development experience. It's what we know our developers love. When they want to do something, they have access to it. So we've been shipping same-day releases for iOS and the new platform capabilities. And like I said, iOS is available. We really want to make it that truly anything you can do in those languages, you can do in C# or F# too. Now, when we talk about those other libraries, we know that sometimes there's an existing platform that you may need to integrate with, or custom hardware. So sometimes those libraries are only in Java or Objective-C or Swift. So what we've done is expose the same technology that we use ourselves to create bindings to enable you to create bindings in C# as well. So if you find a Java library or Objective-C library, you can bring it directly into Visual Studio and create the C# binding yourself and add all those great features. So you're not lost, right? So you can have access to all of that. We have a brand new automatic CocoaPods importer, which is essentially NuGet, but for iOS developers. And what's cool about iOS applications specifically is that they're actually more than phones, tablets, watches. An actual iOS and Mac application are all about extensions. So every time if you're an iOS user, you drop down, you see different widgets and charts, or using things like just getting access to document pickers or iMessage extensions. Those are all extension points that we've integrated into Visual Studio and Visual Studio for Mac, all of these extensions there. Now the problem with extensions is that they're actually separate applications that you ship to Apple. So they're all little things. So this kind of causes a problem because we have that .NET Xamarin runtime that's bundled into your app. And it's not that big because we have an advanced linker and compiler, but every meg matters. So what we've done is instead of shipping multiple runtimes when you ship extensions or watch applications, we have a shared runtime across all of your extensions and your main iOS application. And this is done automatically for you. You don't have to do any work at all. So it's super awesome. Now, we also have Visual Studio for Mac, which I've demoed a little bit in some previous sessions. I'll demo here in a bit. It's essentially the ultimate .NET Mac IDE. So everything I just showed you here can be done, but also including Mac OS desktop development, ASP.NET Core, Docker, Unity, tools for Azure, and Azure Functions as well. It's powered, it's free, boom, boom, and it's available. It's powered by Roslyn, the same exact text editing, has multi-process debugging, and a bunch of great Azure integrations to deploy directly up into Azure, including Docker. Now, what also is cool is that we want to make sure that .NET is in every single application, whether it's written in C# or not. This is really important. This is the final thing I'm going to talk about today of where we see .NET going. When we think of .NET, we usually think about it now on our native devices with Xamarin, on our desktop, and in the cloud. And how we share code between all of these applications is with .NET standard libraries. Essentially, every single platform implements a specific API that you as a developer have access to create one library that can be shipped and consumed in any application. So it looks a little bit like this. You've probably seen this chart over and over again, where you have .NET Framework, .NET Core, Xamarin mobile apps. You'll be adding in other workloads like Unity and a bunch of other stuff that implement all of .NET Standard. And then they each go through their own compilation step, but you have one API as a developer that gives you all of that .NET goodness. It's a standardization of our APIs. It'll all work flawless across all platforms. Now what's cool is as we're extending not only .NET, we want to bring it to all sorts of things. So we have not only Azure IoT, but inside of Visual Studio, we have an IoT stack which features libraries including MQTT and AMQP, which are messaging queues, which give you a very similar deployment to every single major Linux architecture, and they're self-contained. And this IoT stack essentially gives you a way to integrate with Azure IoT Hub. So know that, again, it's not even phones and tablets, it's all these IoT devices that I can build and deploy my .NET C# apps. Now, this is the world that I've been talking about. Shared C# logic, Android, Mac, iOS, IoT, Linux, Windows, ASP.NET Core for my web applications, C# everywhere. This is what I love. But I know that not every developer out there or every corporation, one, has standardized on saying everything is in C#, everything is .NET, or they may be wanting to convert some legacy applications over, which is sad. But we know that there's existing C++, Java, Swift, and Objective-C applications and code bases out there. What we want to do is say, hey, if you're in this scenario, what if you could just reuse all of the .NET greatness that James just showed you, including all those amazing libraries, all those NuGet packages that are out there. So there's no need to actually start from scratch. You don't need to throw away existing applications. You can easily migrate over time to a full stack C# .NET app. So we created a tool to do this. It's called the Embeddinator 4000. And I love this name because it describes exactly what it does. It embeds .NET. It's the Embeddinator. It embeds .NET into native language applications. 4000. Now, what's cool about the Embeddinator 4000 is not only does it have an awesome name, but it's an open source project that takes shared C# logic. You run it through the Embeddinator, and it pumps out native libraries for Android, also non-Android Java applications, so Java server workloads, Mac OS, iOS, tvOS, and even Linux C++ applications to create those native libraries. So now you can start pulling in core chunks and start sharing 10, 20, 30, 40% of your application's logic that's all in C# and use the best tools to do it. So let me show you what this looks like. I'm going to do this demo all over on my Mac. You can also do it inside of Visual Studio, but I'm going to do a lot of iOS and Mac application development here. So I have Visual Studio for Mac. And what I'm going to do is I am going to build a weather application, and I'm going to do all of the business logic inside of here, inside of this project. So it kind of looks like a Xamarin application, But these aren't applications. These are Android Xamarin libraries, Xamarin iOS library, and a .NET 4.5 library. So just DLL libraries. Now what I've done here is created some shared code between them. So I have a weather result, and I have temperature, city, state, temperature, and I have a constructor here that takes in the temp, everything here. And then I've created an Android, an iOS library, and a Mac library here. Now, what I'm going to do is when I go into my options, is whenever I build this, I'm going to run the Embeddinator 4000, which is just a NuGet package that I've downloaded onto my project. This is going to build it up. So I can actually do this here. I'm going to say, hey, let me go ahead. Oh, I should show you like the weather fetcher, because this is cool, right? So this goes in and it uses Yahoo Weather to take that city and state, figure out the current temperature, and parse that JSON using the built-in JSON provider. So I'm going to take that iOS, I'm going to build it. Now for demo purposes, I just pop up this little build tool so I can see the progress here. This is essentially taking all of my C# code, converting it to actual Objective-C archives, and then converting that into a framework that can be consumed into an Objective-C or Swift iOS application. I could do the same compilation for Android and Mac OS as well. Now what this is doing is it's building all, it's going to take a little bit of time because I've specified to build every single architecture type, because there's ARM v7, ARM 8, x86, x64. So it's going to package this up. And when this is all done, it's going to output 3 different output paths. So here I have a Android output that gives me a AAR file, so an R file or a jar. Here I have an iOS output for everything I just compiled, so the archive and the framework. And then I have a Mac, so same exact thing. I can put out dynamic libraries or frameworks. So now that this is finished up and it's all good, we're going to open Xcode. Yep, it's totally going to happen. We're going to open up Xcode. Here we go. I'm going to open up this iOS application here. And what I've done is I've added the actual framework that was converted from C# into beautiful, not that one, that one's not so beautiful, bindings. Look at how beautiful this Objective-C is. So who doesn't want to write that? I mean, that looks great. We give you a perfect Objective-C, Java, and Swift API to develop against. So what I can do here is I've created a little bit of user interface. I'm going to tap on this view controller, things that we learned about already. And here's the Objective-C. And this is what it would look like to actually implement a click handler. I'm going to go pass this off. And when the results come back, I'm going to append on Fahrenheits. And if anything goes wrong, do this. So calling into my .NET code. So I'm just going to run this on the actual iOS device. It's going to attach to the actual iPhone simulator. Here we go. And we're going to see what it is in Orlando, Florida. Get weather. Hot, 91 degrees. Let's see what's happening in Seattle. Wah. Showers. Natch. Very naturally. That's why it's good to be here. So all of that user interface I just created normally, but I'm invoking into that .NET code. That is bananas. But what's even more bananas is that I can come into Xcode here. I'm going to open up the Mac project at the same time. So how do I even do that? Open recent, open up the Mac project, and check this out. I've added the Mac framework into my frameworks folder. I have a view controller, and guess what? It's like basically the same code, but this time I created a native, oh geez, where'd it go? Native Mac application. So let's actually run the Mac app. Build successful. Beautiful Mac app. As you can see, I'm a great designer. Seattle WA. Get weather. It goes out, still showers. But now I'm sharing code between Mac and iOS. This doesn't even make any sense. But now I can even go into Android Studio and check this out. I've added that archive file, and I have the same exact code, but it's a perfect Java API with all those ridiculous underscores for lowercasing for no reason. But it's here, it's fine, and I can get the weather. So I'm going to open up my Android emulator. Here it is. It was cloudy, now showers. It's all right there. But it gets better because at the same time, I can not only just share code, I can come into, let's say, this iOS application, and I can create a native user interface in C# powered by Xamarin, and also access all of the iOS APIs. So I've created a UI view here, and I have a core geolocator to actually get my geolocation. And then what I'll do is I'll just create all the UI in C# or in Xamarin Forms. Right? I could just access this here. I can add the touch-up inside event. I'm now getting all this great native capability. So inside of that Mac application, let's go back over there. Let's close the Mac one. Stop. Come over here into the iOS version. What I'm going to do is a little hack here to just replace the user interface with a weather view from C#. So I'm going to hit go again. And when I go ahead and compile this up, we're going to now see a different user interface to get the weather. There we go, because now it's different. And I can say Seattle. Let's see Cleveland, that's where I'm originally from. Ohio. Any Cleveland in the house? Nope. Nope. One. All right. Mostly cloudy. Or I could say get location. This will do a geolocation lookup and automatically return the simulator's default of Cupertino. And I access all those APIs and created the UI in C#. That is bananas and awesome. So if you have existing applications, need to do anything, we have a way to easily migrate from your existing code bases and share awesome .NET code. Boom. Yeah.
We are on.
Now, I'm over time. We have awesome people using awesome things, like Alaska. That was a video. I'm not going to play it. We got time. They do awesome things with Xamarin. So I'll give you some case studies of how these services work together. Alaska Airlines turned to a completely mobile-focused organization. And they're using all of our services with Xamarin, Azure, Test Cloud, Mobile Center, and Visual Studio Team services. As well, with Coca-Cola, for instance, uses Xamarin Forms exclusively for all of their iPad applications. The consolidating bottle company, as they go out and do all these vending machines, using these powers, whether it's building out those rich user interfaces or leveraging things like Xamarin Forms to build out that shared UI. You can do all sorts of awesome online training with Xamarin University, which is our free and paid online training. If you go to university.xamarin.com, we have about 20 different online self-guided training courses as a full certification, all for free, which is awesome. Then you can take it to the next level to do live interactive classes with the paid version as well. And with that, I wanted to give you a little bit of source code to get afterwards, including the Embeddinator demo, install Visual Studio, go to the actual Xamarin Forms presentation in a bit, and I'm way over time. If you have any questions, come up to me. And with that, thank you so much.